Good afternoon, everybody. Thank you, Philip, for the opportunity to speak here. It is truly inspiring to hear all of you speak and to hear all this incredible research that is happening. My name is Vera Parlac, and I currently teach at the University of Calgary. And I'm one of the co-founders of LID, Laboratory for Integrative Design, that operates from University of Calgary. This coming academic year, I am moving to NJIT, to New Jersey Institute of Technology. So for the sake of time, I chose to talk today only about one project that currently preoccupies me. So it's just a small segment of what we do. So what I would like to present to you today is a project that explores integration of the soft robotic or soft inflatable components into modular architectural surface or structure. And this research actually focuses on new material behaviors and their capacity to produce adaptive or kinetic dynamic material systems. This project is inspired by the rich history of pneumatic structures in architecture, on one hand, but it is also inspired by soft robotics and the soft robots that are built lately that can move or pick up fragile objects by sort of manipulating the inflation and deflation patterns. The idea of integrating soft robotic components into hard architectural modular constructs came from the morphology of a sea star and the fascinating set of tiny muscles that exist in between those plates and allow sea star to move. So we began this exploration by exploring actual component, by thinking and exploring the way in which that component could be aggregated. And we settled on the X-shaped component that allowed us to develop the surface-like, thinner regions of the structure and thicker and more robust and structurally sound regions of the structure. So this, the kinetic architectural surfaces, they most often employ mechanical components. And these mechanical components are often external to the structure. So we were really interested in producing a surface where actuating element is integrated within the geometry, structure, and surface of the material system. So some of these, in our exploration of the components, some of these regions actually were stable enough to support a person standing on them. And this was actually achieved through the slightly very simple variation of the placement of the component within the aggregation. So you can see those blue components. And that allowed us to sort of have these surface-like straight regions and then also curved regions. And it allowed us to actually achieve a kind of relatively smooth transition between the horizontal and vertical direction of the aggregation, and eventually would allow us to form an enclosure that is quite free-flowing. So around the same time, we started to think how to integrate these soft components into the hard body of the modular system. And those of you who are familiar with soft robotics know that the elastic membrane that delineates the body of the pneu structure actually exhibits quite a significant transformation when the change of pressure occurs within the pneu structure. And it is this transformation that is used to produce kinetic effect in a larger surface, because everything that is attached to this transformable soft element will actually be kinetically animated. So we produced several kinds of muscles. You see them here in their dormant and active state. And you can see that sort of change of shape and change of and dynamic capacity that is embedded in the system. And this is kind of what it does when it's integrated within the system. And you can see how the system is slightly differently animated based on what kind of muscles are integrated into the construct. So all of these muscles, these soft kinetic components, are also they are also modular. So they are made to fit within the aggregating pattern of the hard modular components. So we were very interested in kind of strategic positioning of these muscles within the surface so that we can actually choreograph and work with symmetrical or asymmetrical disturbances within the surface. So we believe that this kind of surfaces could produce more intimate relationship with the human body, and that, for example, these surfaces could support the body, or they could open occupiable spaces within the surfaces of architecture that could be inhabited. So this is something that is very exciting to us at the moment. So the aim of the project was to produce a dynamic material system that is at the same time self-supporting, that is pliable, and that is kinetic. And its behavior is governed by the configuration of the modular components or by aggregation pattern, but also by the position and concentration of those soft active muscles. So the project is really interested in tectonics that integrate stasis and the motion. And this is a form of programmable building skin system that exploits transformational capacity of these active structures as ingredients in space making. Thank you.
Thank you very much. I think that was a really very good presentation. I wonder, have you looked into scaling of these
yes,
modules?
yes, we did.
How big, how small could you do?
Well, this is how big we went, this slide that I showed you, which is about twice the size of the models, of the movable models that I showed you. So we kind of scaled it up to this size. That's the scale where we are at right now.
Could you do it bigger? I mean, I just wonder what...
Probably. I think, well, we did another kind of structure with a similar but bigger components that doesn't have soft robotics integrated. You know, when you scale it up, you have to actually, that is a stage that we are currently at. I think right now these models are made of plywood, right? And as you scale it up, it becomes quite heavy. So one way to look into scaling up is actually to look into change of material, whether it's aluminum, whether it's plastic, but that is something that needs to be looked into now.
I hope this is a simple question, but what would be your...
I do not like the sound of this.
It's also a real question. Back in London, there is a young Bartlett MArch student who's very interested in real-time pneumatic architecture. What would your advice be to him in exploring this area of possibilities?
Well, it depends. You see, the history that we look at is really rich when we look at these soft inflatable volumes that envelop the body. And it's here in this project, what I am interested in is how to scale those soft components down and integrate them into hard architectural components. So I would encourage a student to look at the at the ways in which we can deploy these active structures within the material systems, not necessarily offer them as a material system itself. So I would say that because that's what I'm interested in.
Thank you so much.
Sure. Thank you.